Good evening, all of you. I think hope everyone understood little bit about the diode because I'm just dumping so many things because there are so many situations are coming across that one. So I just felt like something okay if I had some information like one, two, three, four. So as far as our level is concerned, I think I just made in the end some conclusion like as forward bias increases, the width of depletion layer decreases and the forward current increases. I think this is enough for us. And the forward bias current is due to what? Due to majority carriers. I think these are the small informations are there. Just like to make you think hard. Okay, that one I just took help of what actually goes on inside. I think because maximum students they go for exact reason, and you search any book. I'm telling this one definitely show the best books are available. Even then, there what happened we don't give information because everything comes through quantum mechanics. What I'm just summarizing it. Therefore, don't fight with the exact cause, just the content you read it and come out of this one. Because you spend any amount of time because we don't know what actually the quantum level, no? That's why you find very hard. Huh? So let me continue the forward bias. Few more, so 2, 3 points are there, then we'll summarize. Okay, now what is the expression for this forward current? Means why the graph is like this. So in this region, what will happen? A depletion layer still exists here. What about depletion layer will vanish or will be very small. You can put it here. Then the depletion layer, what will happen is a non-ohmic and the depletion layer vanishes here. And you look at this for small change, what happen? A large change in current will be produced here. For small change in current, for small change in voltage, a large change in current. Any reason for that? Because it will not be like a Ohm's law, you can say. If it were Ohm's law, it would have been the response would have been straight line. Will I agree? The response would have been straight line here. So therefore, shall I say diode is a non-ohmic device? They can test you with the non-ohmic device. Why that non-ohmic feature? Because of depletion layer only it is. Okay, then why the graph is like this only? Why the graph? Is there any mathematical equation or simply like, okay, it has come? As we do have equation, based on that equation, what happened? The graph has taken shape like this here. Let me write the equation. Here only I'll write it. The forward current is equal to I drift into e to power of, okay, let me recollect. Okay, e to power of this will be charge barrier potential or the forward voltage by kT minus 1. And the equation. What is this I drift is what I'm saying. This I drift it is also called as high saturation. This will be of order 10 to power of minus 12. Let me put it. Very small current. This drift current. This call also called as reverse saturation current. It is also called as reverse saturation current. So I think I'll write it. What is high saturation? Due to minority carriers here. So like this, the forward current account to this particular thing. So as you increase forward voltage, the graph follows based on this equation. That's why we have put it here. Okay, there's a one thing which you have to remember. I think in SU1 there are numericals are there based on this. So any possible questions can be asked here. We have even temperature of the diode. Later on I'll explain. No, at the increased temperature, what happened to the curve? Because what is Q? Q is a charge. K is a Boltzmann constant. This is a forward applied voltage. This is a T is a temperature of the diode. This is a fixed value, reverse saturation current. This will be some based on the diodes. No, it will vary from 10 to power of minus 12 to 10 to power of minus 8. Or some books, what when they took, if SC or my has given 10 to power of minus 18, I think. So different books, they given value on an average, 10 to power of minus 12 to 10, very small current that due to minority carrier current. Okay, got this. So this is about the graph, which you have to remember. And this based on this equation, any questions can come. Now, as I increase temperature, what will happen? If I increase temperature, the curve will shift. No, this is the temperature T1, T2, T3, and this is a forward voltage. Not a barrier voltage. Huh? This is a forward voltage. What happened? From where there come voltage applied across the cell it is, and there's a forward current. Now, anything about the temperature? So these are in degrees Celsius. Huh? Anything you can put it, no problem. No, anything can you say T1, T2, T3? How to? I just put like this. Huh? T1 greater than. For any reason can we put it here like? At the increased temperature. Okay, this graph, can you remember? I'll take you back to again the same diagram. Everything, I think our explanation, everything will revolve here. Earlier, what happened at a given temperature? Okay, the most energetic electron from the N will cross over to P, and the most energetic hole from P will cross over to the N. What about 2? What about 2? It was not having sufficient energy. It was supported by the cell only. Due to cell only, it was able to cross. On its own, it's unable to cross because of the thermal agitation. It's unable to cross. Now, at the increased temperature, along with 1, the 2 also will get energy, no? Due to increase in temperature. Go back to root mean square. What is the average kinetic energy? We write 3 by 2 kT. Because this electron is like a monoatomic gas, no? So as you increase temperature, the average kinetic energy increases. Then, so this, like as you increase temperature, earlier only 1 was able to cross. Get this one, and the 2 was able to cross due to the cell. Let's take some 3 I took it, no, some 4. 4, though even the cell is there, temperature is there, it was unable to cross. If I increase temperature, due to average kinetic energy increases, then it will have sufficient energy to cross. So therefore, as you increase temperature, what happened to amount of majority carriers crossing the junction will increase. If majority carrier increases for a given voltage, I'm not talking about this particular, I'm not talking about I'm going to vary voltage for a given voltage. So let's take that 1 is able to cross, 2 because of cell. There is another, say 4, which is unable to, I'll give the number. The cell energy supplied by the cell is not sufficient, so it is unable to cross. Even what will happen? Due to average kinetic energy is not sufficient. If I increase temperature anyway, 1, 2 will cross it. What happened? 4 also able to cross, no? So what will happen now? For a given applied voltage, more number of majority carriers will cross the junction as you increase temperature. For a given voltage, more majority carriers. More majority carriers means more forward current. So come for this. For a given voltage, you draw a line. You have to draw a line like this. Huh? You have to draw a line like this. So for a given bias voltage, as you increase temperature, more majority carriers will cross. So therefore, shall I put T1 greater than T2 greater than T3? You have to draw a vertical line. So here for a given bias voltage at temperature T3, okay, few majority carriers were crossing. At the increased temperature, number of majority carriers crossing will increase. So will increase. So there's a reason. So like this, no? So these things are not there in most of the books. Definitely the NIT process will show interest in setting such questions here. So what is the reason we have to give? As the temperature increases, number of majority carriers crossing the junction increases for a given bias voltage or applied voltage across the diode. Yeah. For a given there's a reason, no? We have to give reason like this here. And now you can ask also questions. So like what you said temperature increases. Then what will happen to the covalent bonds in depletion? They'll also increase. But the proportionality, if you look at the amount through which the majority flow of majority carriers increases, no, that will be superseded due to minority carrier current. Means what I mean to say that here also as you increase temperature, more covalent bonds will break up. But as I said, they are minority, no. So definitely what happened? The flow of majority carrier will be very much greater than the flow of minority carrier. Even the drift current also will slightly increase, no doubt. If increase temperature, covalent bonds, number of covalent bonds breaking up here will increase, the drift current will increase. But if you check the amount of increase in diffusion current will be very much greater than drift current. So that the net current will increase. Because what is the net current? The difference of these two. Because they may trouble you with this one. Huh? So if you increase temperature, number of covalent bonds will break up. The drift current will also increase. But if you look at the increase in diffusion current will be very much greater than the increase in drift current. So therefore, the net IF will increase for a given voltage. You have to analyze for a given voltage. It little bit easier. Fine. So there's about the temperatures like this. Okay, do remember at least they may ask reason or they may ask you graph. The curve will shift to the lower that one. It has to be. Now again, if you take the slope, so definitely what will happen to slope? A slope will change because this one. So do analyze that also. Okay, this is about the basic idea of the forward bias. Okay, now we'll go for the reverse bias. I think I'll like to do in rest. I'll give that also reason. Even or let me put in simplify. Increase in diffusion current will be very much greater than the drift current due to rising. I'm not saying drift current will not change, will change, but it'll be far negligible compared to the change in the diffusion current. There's a reason. See, if really the professor wants to test, if he asks this, only students who has really analyzed, they can answer. But any exam, you can't think this much here. That much I can say. You must be ready with this one. So just we don't know. Some professor he really wanted to test your concepts. He may test you all these things. Keeping that safety parameter in the mind, I'm just going for the additional information. Reverse bias. What is the reverse bias? The p-type will be connected to negative terminal and n-type will be connected to positive terminal. And we have to study the characteristics graph here. So let me take the same diagram, this one.